also sent you that sample video that Aditya made, right? Have all of you seen that video for the first experiment?
Yes, sir.
So, do you have any questions, first of all, on what to submit, on how to make the video and all that, right? So, let me also just set the benchmark here. Aditya has done a wonderful job of actually making that video. Let me tell you what is optional. It's okay if you don't add background music. Okay, it's I leave that aesthetic part to you. If you think, but it should definitely, background music should not interfere with your narration. Okay, if you would like to hear what you understand of the experiment, it's okay if you do not, if you want to draw something on paper and then show it like that. But my only request is, if you do draw something on paper and you want to show it in the video, please take a photograph of that paper and then put the image in the video editing software. That makes it much easier for you to, show a high quality image. Okay. So for example, Aditya had, taken a snapshot from what I had given saying, this is the circuit we are trying to do. That's also a very clever thing to do, right? You can take a snapshot from that video. Or if you want to draw something and show, please take a photo of that and put it in the video editing software, right? So as what is really needed is, we want to see you, your roll number, ID card, your understanding of the experiment, a short, this thing, of course, the breadboard and all the components arranged and all that stuff, maybe a couple of seconds of you tuning something and running the experiment. In this case, Aditya had focused on tuning the potentiometer, right? So that is something you can show. And finally, we want to see all the readings, right? I want that also to be part of the video, like the Excel sheet where you are noting down the values and then you select it and plot the graph and show us right there. If it is about plotting the graph, like it was in the first case. Okay. These are my initial comments. Okay. It's, I feel it's very good to set the, it's very good to set the uh, benchmark at what Aditya did. But we are not here, we are not going to grade you on your video editing skills. We want you to show the technical aspects well. That's all. Okay. So, any questions, first of all, on the
Yeah.
first experiment on the video?
Sir, like I have the question on the VTC curve. Sir, like
Yes.
the VTC you made in the V lecture is not matching of the VTC we try to made.
Okay. What was not matching?
Sir, the intermediate region. Sir, you got the
No,
intermediate region between 2.0 volts to 3.0 volts, approximately
absolutely.
2.7 volts.
Yeah.
And we are getting the intermediate region approximately the threshold voltage is 1.0 volt. That is 0.7 to
Correct.
2.0 volt.
That is perfectly possible. That is perfectly possible because the NAND gate IC that I used would be slightly different from yours. It would be 74LS00 versus 74HS00 or something.
Sir, I
Okay.
guess you
And
used an IC with the transistor CMOS, and we are using TTL transistor one.
no, 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 no. All of us use TTL only. The same TTL transistor can be programmed, can be sized, can be made in such a way that you get the trip point close to 1 volt or the trip point to 2 volts. It's possible. It's actually in the name. So if you zoom into I'll tell you a simple thing. You zoom into your IC, okay? Take a magnifying glass, zoom into your IC and see what the name of the IC is. Similarly, in my video, no, try to zoom in properly and see what the IC name is.
Okay, sir. Sir, can I
Okay.
reprogram that IC?
No, no, you cannot reprogram because that is based on the manufacturing process. That's all.
Okay.
Once manufactured, you cannot change it. Okay.
Okay, sir.
Yeah. Any other questions? This is being recorded, right? Yeah. Okay. Cool. Very good. Yeah. Please tell me any other questions on the first experiment on the VTC. So by now, by now you should have figured out how to identify the ICs, the notch on the IC and how to count the pins. Correct?
Yes, sir.
Does anybody have a question on that? It will be the same thing that they do for all the ICs. Everywhere you have to look for that notch and count. Okay. So what we will start doing now is going forward, uh, the the number of the instruction level at spoon feeding will start coming down, because in the first experiment, like I even showed you how to make a probe wire and all that. You will have to use all of that going forward in other experiments as well, but I will not be demonstrating those things in every video, right? In some cases there might be no video, like what we are going to do in experiment 2, right, compared to experiment 1, in terms of the complexity and in terms of the breadboard complexity. It's a very simple experiment, and therefore they have already emailed you the instructions. Is that correct?
Yes, sir.
It has been configured. You have seen analog experiment 1, correct? This is some Wheatstone's network
Yes, sir.
type of thing, correct?
Yes, sir.
Yes,
So
sir.
you know how to, you have to put them on the breadboard and basically essentially do it, right? So now, one other interesting thing that Aditya, showed, and in fact, I didn't even know it existed, right? Was this breadboard planner, right? Aditya, can you just tell us about that breadboard planner?
Yes, sir. I hope I'm audible properly.
Yeah, and you can also turn on your video for this if possible.
Yes, sir. Just a minute.
Yeah. Yeah, I can see you. Please proceed.
Yeah. So basically, the software that I used to make that breadboard was a software called Fritzing. It is basically a software that is introduced to students who are, basically getting into programming using Arduino boards. So that was one which I had learned a long time back. So I thought it would be a good idea, to show the connections that I did. So the person who is grading that video will get an idea of what exactly I did. And if there is any mistake or something, he can point out to that exact pin where I did something wrong or did something right. And yeah, so basically Fritzing, the app is Fritzing, and yeah, I recommend that all of my fellow classmates and batchmates also use it to make their tasks easier and make it simplified.
Okay, good. Thank you, Aditya. So, I see this thing in the initial experiments, we have only one IC, right? So it is not, I would say it's not mandatory to do, this kind of a software-based thing. But going forward, right, the final experiment will involve like multiple ICs and lot of connections. Okay. In that case, I think this breadboard planner would actually come in quite handy. Before you go ahead and actually assemble the ICs on the breadboard and all that, please spend some time planning it, right? And so, Aditya, can you do one session at some point to just tell people how to use it?
Yes, sir, definitely. And
Yeah.
if it's possible, they can also search it on the internet or Google. I'm sure that there are multiple tutorials as well. It's a very user-friendly interface. So yeah, and yeah,
Okay.
I'm definitely
Yeah.
open
In
to
that case, you just do one thing.
learn
You
that.
just share those videos saying, people can
Yeah.
look at this to understand how to use it. Okay.
Yes,
Whatever
I
tutorial is
definitely will
available on the
share it.
internet, please share it so that people can watch that. Okay.
Yes, sir, sure.
Okay, great. Okay, so now again, so I'm assuming that people know how to, know what to submit. So Victoria, have you created that page where they can submit the videos? Yes. So the Google form has been sent for assignment 1. Okay. So assignment 2, do any of you have questions? Assignment 2. Have you had a chance to look at the question?
Yes, sir.
Hello, sir.
Yes.
Yes, sir. Just a few minutes back only I saw that question. So, could you give us some brief about that? It would be helpful.
Yeah. Wait, can we do that? Okay. Okay. So the objective of this experiment is to construct a Wheatstone's bridge using resistors, calculate and measure the node voltages and its output voltage, right? Adding capacitors. Additionally, to investigate the effect of adding the capacitor across the output to filter unwanted AC components. Okay. So they have basically very clearly told you how to build it. In fact, the Wheatstone's network was discussed in the was in fact discussed in one of uh, the videos in electronic systems thinking, right? About what the impedance is and stuff like that. So the way they have basically said it has to be done is 400 kilo ohm resistors, okay, R1 to R1, R2, R3, R4, and some few more resistors, multimeter and stuff like that. Okay, so so the point is they're basically telling you how to do a balanced measurement and an unbalanced bridge, right? So along with low pass filtering. So I mean, so I'd like to understand what is it that you want me to explain, because from the document, and given that you had already come here for doing some electronic systems thinking lab with filtering and all that, do you have any specific questions that you would like me to address?
Yes, sir. The last section.
Ah, last section is what? Low pass filtering?
Yes, sir. So, how effective can we do that? How are we supposed to do showcase that?
Okay. So what they're basically saying is you make the bridge, retain the 1 kilo ohm resistor that was introduced in part 2. So what they are saying is in part 2, you have to add a 1 kilo ohm resistor in series with R1. Okay. That means the resistance on that side of the on that arm will become how much if I add 1 kilo ohm?
It will be 1 kilo ohm more than that.
No, but what is the original value you added there? What is the original value you added? What was the original
101,
R1 to
sir.
R4?
101
Huh?
kilo ohm.
So
Yeah,
100 kilo ohm,
R1
it
is
will become
100 kilo
101
ohm.
kilo ohm, right?
Yes,
Now
sir.
they are
Yes.
saying add another 1 kilo ohm resistor in series with R4. Okay, so therefore
Yes,
you
sir.
have
So
introduced
$102
an
kilo.
imbalance in the
Correct.
bridge, right? So what is the
Correct, sir.
condition for the Wheatstone's network to be balanced in this circuit?
R1 by R2 equals to R3 by R4.
So what have you done? You have increased R1, you have increased R4. So clearly R1 by R2 is not going to be equal to R3 by R4, correct? And therefore you can have
Yes.
some current going through the terminals A and B,
Yes, sir.
right? So now what they are saying is add a capacitor across the output terminals. Okay.
Yes, sir.
Measure and record the output voltage using the multimeter. Measure the RMS value using the oscilloscope available in the analog board. Okay. So effectively what they are saying is, of course, now because this is, AC, you want to basically study this, repeat the, you have to give an excitation of 2.5 plus 1 sine omega t volts. Okay. You have to feed
Yes, sir.
the input at that frequency, and you're going to see what is going to happen. Essentially, this is a very similar to the filtering experiment that we are talking about. You remember
Yes, sir.
when we
So
did the
we
low
can
pass filtering?
basically,
Yeah.
so we can basically go with the step-by-step procedure which is given in that, right?
Yeah, exactly. Right. See, effectively, what do we have now? You have a voltage source that is connected between, let me see, that is connected, to something, and there is an equivalent resistance, and the output is being taken across the nodes A and B across which a capacitor is connected, right?
Yes, sir.
So, what does this mean? This basically means there is some equivalent resistance, some capacitance there, correct?
Correct, sir.
So that's all we are asking, right? So this is basically very similar to your low pass filtering experiment that we did.
Yes, sir.
Okay. So
Yes, sir.
I would say, some of you have to start doing this experiment, right? Come to a certain point where you have very specific questions and then we can answer. So that's why, for example, for experiment 1, the deadline is Wednesday, right? The deadline for submitting your video is Wednesday. Okay.
Yes, sir.
Likewise, for experiment 2, it will be next Wednesday.
Yes, sir.
So you can try the experiment. If you have any questions, I will address them next Monday. Okay.
Yes, sir. Yes.
Or in
Yes,
fact,
correct.
even I can ask Professor Anirudhan to be available next Monday if necessary. Right?
Yes, sir. Yes.
And whatever
Yes, sir.
doubts you have, you get it clarified. And then the video has to be uploaded only by next Wednesday. You have 2 more days after that.
Yes, sir. Correct.
Okay. Yeah. So
Yes,
I
sir.
think the aim is as follows. If you ultimately given a data sheet, given some basic outline of what to do, you should be able to assemble this experiment and measure it. Okay, that's why we don't want to give videos for every single experiment. Some things you must have learned from the previous one and you must be able to do it now. Okay,
Yes, sir.
so
Yes,
for
sir.
the next 2 experiments, including the digital, I will not be providing explicit videos. I will just be giving some instructions of how to do it. And of course, I will be here. I will answer some
Yes, sir.
questions. For the third digital experiment, again, we will go back to video.
Yes, sir.
Okay.
Okay.
Because that is going to involve many components, many ICs and all that.
Yes, sir.
Right?
And sir, the second experiment, what it will be about?
Which second digital experiment?
Yes, sir. Yes.
Second digital experiment is basically uh, the idea. See, suppose you have a combinational circuit with n inputs. How many input combinations are possible?
2 power 10.
2 power n. Correct. Yeah,
Yes,
I
sir.
say n inputs. Right. Now, if you want to verify if so now let us say you have implemented some circuit. Okay, with some Boolean logic, you have implemented that function. How do you guarantee that function, that Boolean function is correct?
By verifying it with the truth table.
Now for the truth table, how many input combinations do you need to give?
Sir, 2 input combinations. No, sir.
No.
2 to the power 2 input. 2 to the power n input combinations.
Correct. To the power n, right? Now,
Yes, sir.
the point is, if let's say, you are connecting each input, right, to either VDD or ground, right? Imagine if you have even just 4 inputs, okay? You have to do 16 connections to VDD ground, and all that stuff on the breadboard to check for all 16 combinations, correct?
Yes, sir.
Yes. So
Ah,
we'll be using a
that is
counter instead
actually
of that. Like that.
exactly. We will be using a counter where we give a clock and then you will get the counter will basically count from 0 to 2 power n minus 1, right? And therefore, at every time, basically you will go through all 2 power n combinations in a periodic fashion. And you can just connect this to your circuit and see if the output is correct. All the 16 combinations across all the 2 power n combinations. So the next experiment will be just taking a counter and building this 2 power n combination generator.
Okay, sir. Yes.
Okay.
Yes, sir. Yes.
Yeah.
Thank you, sir.
So any other questions? So I am assuming all of you, since nobody else has asked a question about experiment 1, have all of you been able to complete experiment 1? Anyone who's not been able to complete experiment 1?
Yeah, here, sir. Gaurav here.
Yes.
Yeah. So experiment 1 asks us to find out the voltage transfer characteristics of NAND gate.
Yeah.
Right. So by that we mean we need to plot the input voltage against the output voltage.
Output versus input. Yes.
Yeah. So from the instruction video, I got to know how to handle different equipments and the components that are to be used in this experiment.
Yeah.
Means it mentions that we will need 2 voltmeters there.
No. I already mentioned that you can either do it with 2 voltmeters, or alternatively, you can also do it with 1 voltmeter and 1 ADLM kit.
Yes. Okay. Okay.
So you please see Aditya's video now.
I think I missed out that part of the meeting since I joined in a bit late. So
No. So see, there is a video that has been circulated saying this is how you should submit, no?
That is that on Discourse or where will I find it?
This is, I should have, where was this video sent? It's on the study Gmail. Right? Yeah. So can you check your study.itm.ac.in email?
Okay.
Yesterday it was sent.
Via email, is it?
Sorry?
The video link has been shared via email, is it?
Yes. This is basically a video link of one of your own fellow students, Aditya, who
Got
has
it.
seen the instructions and done the experiment.
Okay.
So you have to do something very similar.
Okay. So basically we won't be needing 2 separate voltmeters. One is ADLM kit and one is a voltmeter that we'll have to use.
Exactly. But if you have access to 2 voltmeters, you can also do it like that. So we have no problem you doing it in any which way.
Yes. Thanks, Michael. Okay.
Okay.
Thank you, sir.
Yeah.
I'll look at the video link that has been shared through email.
Yeah. Please follow that. Yes.
Thank you.
Okay. Any other questions on assignment 1? Okay. Yeah. Please tell me.
Sir, since you
you mentioned that we'll be checking out, we'll be creating a Wheatstone bridge and coupling it with RC filter,
Yeah.
right? So what exactly is the objective of that setup?
No, the idea is to look at and understand the Wheatstone's balanced bridge and unbalanced bridge, and also look at how you can filter out the unwanted AC components. See, the objective is written here, no, in the this thing. Additionally, to investigate the effect of adding a capacitor across the output to filter unwanted AC components.
Okay.
Yeah.
Okay.
Thanks, Michael.
Thank you.
Yeah.
Hello.
Yes.
Professor, the supply to the Wheatstone bridge will be DC. So basically,
Yes.
the AC component, how will be noticing that what the filtration is happening?
No. Supply, again, you read the instructions. There are 2 sets of experiments that you have to do. First, you give only DC 2.5 volt. Okay. The second is you repeat. You see part 1, instruction 6 says repeat the above study with excitation of E equal to 2.5 plus 1 sine omega naught T.
Okay.
Yeah.
Yeah, that makes sense. And
Okay,
Professor, one more question. This assignment submission in the video format, we have just recorded on through the mobile. Will be that okay? Just a raw video we can share in whatever form it is.
No. See, there are 2 things. No, I told you. One is you're recording with the video, your setup and all that. right?
Yeah.
Somebody is recording you doing the experiment. Now, what about your screen capture where you have captured the video for, the plotting the waveform and all that?
We have shown in that video the screen of the laptop. Will be that
Okay,
okay?
see, I think, okay, what you do is, can you send me your video? I will take a look and let you know if it's okay or not.
Right now, shall I send it?
Yeah, send it to me and Victoria.
Okay, I'll send it. Yeah.
Okay, I'll take a look at it. But see, my only point is it should be clear. The reason I'm asking you to do screen capture and combine it, by through some basic video editing is the pictures will be very clear. If what you're sending me is not clear, then I might not approve it. Okay?
No.
But if it is clear, I'm okay with it.
Okay, I'll just share with you. Then you can give me your consent on it.
Done. Please do that.
Yeah.
Okay? Done.
Yeah.
Okay.
Sir,
Yes.
sir, instead of using a voltmeter and an ADLM kit, can we use the ADLM kit, the channel A and channel B? Channel A for input and channel B for output.
Channel A for input, channel B for output. You can.
Yes, sir.
But the multimedia meter is needed. So it's not that you can get away without a multimeter. See, because tomorrow you will be building, complex circuits with multiple ICs. You have to do continuity test and all that stuff.
Yes, sir.
Okay. So multimeter is a much faster way of checking. That's why we assume you have one multimeter and one ADLM kit.
Yes, sir.
Yeah. But you can do it with just the ADLM kit also. Yes. Yeah.
Sir, since you mentioned about the usefulness of the breadboard planner, I'll make a short video on it and share it to you on share it to you and
that would
Victoria
be
ma'am
very
through email,
useful.
so you can
Yes, that would be very
approve
useful.
it, and so that it will be useful for my classmates as well.
Yes,
I'll
yes,
share it to
absolutely.
you through email.
Yes.
Yes, sir. Yes,
Thank you, Aditya. Yeah.
definitely. Yes, sir. No problem, sir.
Yeah. Yes. Any other questions? Okay. If there are no other questions, we can close for today. Like I said, please try experiment 2. If you have any questions, next Monday I will answer them. Maybe I'll ask Professor Aniruddhan also to be here, right? And then you'll have 2 more days to make any corrections and submit by Wednesday. Okay, that's the plan.
Sir,
Yes.
sir, could you say something about what we will be doing in the lab?
Yes. So the idea is that it's still experiments. At least you will be building slowly towards a counter. Okay. Ultimately, I want you to build a circuit that is representative of this traffic signal counter that you see. Right? You see something counting down when you are at a signal, right?
Yes, sir. Yes.
So I want you to build that. Okay. Now, what is the bare minimum? Is using 2 7-segment displays and 2 7-segment drivers. You should be able to do that. Now, there are certain advanced experiments which also I have planned for those of you who finish the other experiments easily and all that. You are free to go ahead and try some advanced experiments also. Okay,
Yes,
I will
sir.
upload that also. So effectively, we start from this, for example, experiment 2 is this counter. I'm saying digital experiment 2 is counter.
Yes, sir. Yes.
Then after that, we go to binary to BCD, I mean, binary coded decimals. Okay, converters.
Okay, sir.
Then the last digital experiment will be to drive that binary coded decimal into a 7-segment display and then make it count appropriately.
Yes, sir.
Okay, so you will be building on the previous experiments. Step by step,
okay,
you will
sir.
be building.
Yes, sir. Yes.
Sir,
Okay.
can you just like share the details of that project in later on? Because that something can be done earlier if we can just design it priorly.
No, I will do it. I will do it. I just wanted to see where all of you are today. Okay,
Yeah.
because the first experiment, I didn't want to overload you guys and scare you suddenly, right? So I will
Because
upload. Yeah.
Because what you mentioned, I think that is something very similar. I have made it already. So I would cross check if it's similar, then I have already prepared it like that. So I would be prepared for that in future.
Okay,
I
excellent.
just
No, then
mentioned
I will
that.
do that. I will do that. Okay. Done.
Yes, sir. Thank you, sir.
Okay, right. Okay then. Thank you all. Okay. See you next Monday.
Thank you,
Yes,
sir.
sir. Thank you, sir.
Thank you, sir.
Bye.
Thank you for your time.